Hi guys, a quick video on marking out more than anything, I suppose. We're going to mark out and then cut out and make one of these Sgian brews. A bit like a Sgian do, but with a bottle opener instead of a blade on the end. A bit more user friendly, a bit more student friendly. So that's the kind of thing we're going to end up with. It will have some handle material mounted to it so you can actually hold it comfortably, and maybe even you could persuade Mr. Gibson to go and find some leather and make a leather cover for it, so you can actually, it looks like a proper Sgian do then, but as I said, it's got the bottle opener in it instead of a blade. So what you can make it out of anything you want really. This is a piece of mild steel that is what, 3 or 4 mil thick. You can use that, you can use a little bit thicker if you've got it, you can use a little bit thinner if you've got it. There's no need for fancy steels really, fancy knife making stuff, not necessary, because the mild steel is more than strong enough for use as a bottle opener. I've got a bit of steel here, which I have no idea what it is. It's just about long enough, I think. Maybe it's a little bit too short, but it won't matter for this demonstration purposes. First thing to do, what you will get probably is a bit of mild steel with some mill scale on it, the black stuff, which is really hard and makes your life a wee bit harder than it needs to be when you come to marking these things up. So the first thing is to get some emery cloth, 80 grit, 120 grit, something quite abrasive. And it's to get that mill scale off. Once you've got the mill scale off, you've got some reasonably shiny metal underneath. You can then apply some engineer's blue. This is a fancy engineer's blue pen, but you might just be applying it with a paintbrush or a foam brush or something. Now, engineer's blue is just like really watery nail varnish. It's not gone on particularly well, that, but it dries really quick. And the advantage of using engineer's blue is that when you're using a scriber, ta-da, in order to mark things, that scriber will be able to see the scratches that the scriber makes. So I've got some tools hanging around the place. There's my scriber. I've got a little engineer's square. Yours will probably be a bit bigger than that. I've got a normal centre punch and an automatic centre punch. I've got a rule. Can't call it a ruler anymore, but someone told me off. That's a 300mm or a 12-inch rule. That's a 6-inch rule or a 150mm rule. So we've got rules of different lengths. We've got some screw calipers. It's a bit like a compass, only it's got points on both ends because it's meant for scratching. And we've got some odd leg or Jenny calipers, and they're used for marking lines in the middle of something or something parallel to an edge at least. Now, whilst I've been talking, that engineer's blue is sort of dried-ish. If it's shiny like it is there, it's probably not quite dry yet. But let's have a quick look at the drawing first. You'll notice that all the dimensions on this drawing come from a single point. So we've got 27mm to the first hole, 39mm to the next hole, and we're all coming from this datum point here. Now we do that for a couple of reasons, the main one being that you don't get cumulative error. Oh, that's a long word. Errors don't build up as you go forward. If I take that from there to there as 27mm, and then I take a measurement from there to there, and then a measurement from there to there, if I've made this measurement, this first measurement wrong, then this measurement's wrong and this measurement's wrong, and all the other measurements that are based on it are wrong too. If you take every measurement from a single point, then there to there is going to be right, if there to there is going to be independent of whether that's right or not, from there to there is going to be independent of the other things as well. So each one is independent of whether you've got the last measurement right or not. So worst case scenario, one of these might be in the wrong place, but not all of them, which is the kind of what happens if you allow those cumulative errors to build up. Now we've got 1, 2, 3, 4, 5 holes. We've got another hole to be drilled there, and then this is actually cut in with a hacksaw and joined up to the tangents of that circular hole in order to make this little mouth that actually opens the bottles itself. And you'll find that both ends are nice and rounded, nice and safe. Can't do any damage to anything. And that's what it'll look like in the end, or you might actually manage to get your holes in the right places, so you can see that they're not quite centre. But there will be a handle over there, and the handle will be held in with some pins that go through those 2 holes there, so it doesn't really matter. Although you should try and get things as accurately as you can. Now, this piece of stock bar here I've got is actually 30mm across. Oh, I thought it was 30mm across. It's not, it's bigger than that, it's 32mm across. My drawing actually, as you can see, that dimension is 30 millimeters. So what I'm going to do is draw a centre line down my component body. So my centre line of my component is going to be 15 millimeters in from one edge. So I'm going to mark my Jenny calipers, or set my Jenny calipers to 15 mil, and then move them out. A little bit awkward. These would be a lot better, I think, if they had the old screw control, like you have in a set of screw calipers. But they tend not to for some reason, not sure why. It's just quite stiff. You get reasonably accurate results with this. That looks like 15-ish to me. And then you can run down that piece of material and you should be able to see quite a clear line coming through. And I know that it's going to be straight because it's following the existing straight edge of this piece of stock bar. So that's my centre line that I've marked in there. It's a bit stripy, that engineer's blue, which is not great. First, the next thing I'm going to do is actually bring in a line from this end, so I can mark that. Now you'll see that both of these ends are actually rough sawn, they're not square, so I can't really rely on that and use my Jenny calipers in this case to run a line down there because it'd be wonky. So what I'm going to do is I'm going to use my little square and I'm going to make sure that I've got at least 5 millimeters from the end, which I have. And then I'm going to actually scribe a line just there. Now where those lines cross over, just there, that's going to be my datum point. So that's going to be that point on the drawing. And because I'm going to use these other spring calipers, I'm just going to put a little centre mark on there. It's quite a natty little automatic centre punch that will put a little centre punch mark just where those two lines cross over. And that lets me then have a really good location for that side of my screw calipers. Now, next thing to do is to start measuring off. So I've got one there at 27 mil, so I'm going to get my ruler out. I'm going to set these calipers at 27 mil, which is there. And I'm going to put one end of my calipers in that little centre punch mark that I've made, and the other one I'm going to make a scratch with along my centre line. And that's the position of that 27 mil hole. Next one, I should have a 39 mil hole. And what I like to do as well, as I do this, I'll just take that. I've done the 27 one, now it's the 39 one. This helps if you cross them out on your drawing. I know there'll be all sorts of engineers jumping up and down that you should never do anything on a drawing and it should be perfect copies, but we have the luxury these days of printers that will bang you out your own copy of these drawings. So that's 39, which is the next one. So that one goes there. So that one is marked at 39. Next one is 52 to this hole. So I'll set my calipers. There's a theme developing here, have you noticed? Set my calipers to 52. And again, using this data, make sure that all these, the accuracy of all these is independent. But these are sort of the same distance apart, which is sort of what you can see by your engineer's eye. And the next one is 65. Unless you're following this in real time, you might want to fast forward this. So it's slightly tedious to watch, slightly tedious to do, in honesty. There you go. Be worth it when everything's nice and accurate. So that 65 is the position of the next hole, which is that one. Then we've got a 78, which is the position of this final hole underneath the handle. 78, which is from there to there. 78. That 90, oh no, we've got another one there actually, haven't we? So we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Sorry, that 90 actually is, that dotted line indicates where the handle comes in. So that'll be where the handle covers this part of the Sgian brew up. So we're not going to mark that in currently because we don't need to. It's not part of cutting out, it's something to help us position it later on. What I am going to mark in are these 2 or 3 final positions. So we've got one at 125, which is where this 10mm hole comes. So I'm going to set my calipers to 125. Now I've got a set of calipers there that's too small. So just bear with me a second. I'll try and find a set that's bigger. in amongst all my old tools that I have. Some big ones, from 1942, these ones. Last used during the Second World War. So as you can see, some of these have got a quick release mechanism on them. I think these are quick release. I'm just going to prove me wrong if they're not. No, that's a not quick release. Some of them are, some of the nuts that you can slide up and down quite quickly and easily. I think these are more like map makers ones, but you know, for navigation calipers. But what am I aiming for? 125, aren't I? So I don't need to be that far in. So that's about 120. Of course, there are different methods and different ways of marking things up. At a push, you can just use a ruler or a rule. So that's at 125. It would help if I actually went over the centre line. There you go. There's the position of that cut there, which is at 128. So let's set that at 128. So basically what you're doing is you're trying to accurately draw or redraw the contents of your drawing onto your workpiece. All right, so that's that line there. And then I've got one all the way at the end here at 154. Now I have a feeling that my piece of material here is not quite long enough.